All right, welcome to Unit 25, where we're talking all about circles. I know, super exciting stuff. First off, circles are nothing like polygons because it's a circle. There are no straight edges, all right? Start with that premise and go from there. All right, a circle is a closed curve in which every point on the curve is equally distanced from a fixed point called the center, all right? The circumference is the length of the curve line that forms the circle, right? So that's the perimeter of a circle is called specifically a circumference. A chord is a straight line segment that joins two joints in the circle. The diameter is a chord that goes straight through the center. So we have diameter, and then half a diameter from the center is our radius. And that's a straight line segment that connects the center of the circle with a point on the circle. All right, so an arc is part of the perimeter. So AB would be an arc. AP could be an arc. Um, uh, so that would be called minor arc. And then if we go AB, APB, that would be a major arc. Okay? The longer arc, major arc, smaller arc, minor arc. Pretty straightforward. A tangent is a straight line that touches the circle at only one point. So DE, right here, that is a tangent line. It touches the circle at one point and one point only. The secant is a straight line passing through the circle and intersecting the circle at 2 points. So here's a line going through the circle, and it can be anywhere in the circle, but it passes through 2 points. So it passes through here, it passes through here. All right, that'd be a secant line. Secant line. A segment is a figure formed by an arc and the chord joining the two ends. A sector is a figure formed by two radii, so like it's a piece of pie. Central angle is the angle whose vertex is at the center of the circle. An inscribed angle is an angle in the circle whose vertex is on the circle and whose sides are chords. All right, so let's take a look at this visually. So segment, okay, that'd be if you ever had a round pizza, but they cut them into square pieces, those are segments. All right. Chord is this line, okay. Uh, Sector, piece of pie. The arc, O would be your central angle. Radius, yeah, so on. Think you guys can see that? I'm hoping so. I see heads nodding. Not really, but in my mind I do. So we'll go with that. All right. So, like I said, O is the central angle. Now, if I look at R here, that's an inscribed angle. Okay. It's an inscribed angle. The circumference of the circle is either pi d or 2 pi r. Okay. That would be the circumference. You don't need to know this, but the area of a circle is pi r squared. It's one of those things that may come in handy at some point. But for this step, you don't need it, but area is pi r squared, and circumference is 2 pi r or pi d. This little symbol here is pi. In our calculations, all of our calculations, pi will equal 3.14. That way, if you're not using the pi key on a calculator, your calculator may go further out than mine. It slightly throws off the calculation. Just use 3.14 and we will be good. So it says, what is the circumference of a circle if the diameter equals 14.5 inches? Round your answer to three significant digits. All right, so 14.5 times 3.14, right? That represents pi. And that will be 45.5 inches. There we go. And you notice they use the approximate symbol again. So yeah, just for your knowledge that it's not exact. Right. Then we have the length of an arc equal to the ratio of the number of degrees of the arc to 360 degrees times its circumference. All right. So if we know the arc degrees, we divide that by 360 and 2 pi r. And if we know the central angle, divide that by 360 and multiply it by 2 pi r. And where do we know 2 pi r? It's the circumference of a circle. Yes. Yes. Well done. You. Good job. So to determine the length of a 65-degree arc on a circle with a 4.2-inch radius. So the setup, 65 degrees over 360 degrees, and then times 2 times 3.14 times the radius of 4.2 inches. All right. So let's see how that looks. Yeah, right there. So this is 5 over 360 multiplied by 2 times 3.14 times 4.2 inches will give us 4.8 inches. All right. These are pretty straightforward. You just have to remember the formula, make note of it, mark it down, put it in your notes. It'll help you on the test. All right. A radian, which you'll come across in physics, and also if you take the mathematical side of trig, Math 112, you'll come across it there as well. It's another way of measuring um, degrees. Okay, it's just a different type of measure. See it in the aerospace industry a lot. So one radian is equal to 180 degrees over pi. Okay, or this, but I would use 180 degrees over pi to be more accurate. All right, again, standard substitution, it's proportion, easy to calculate. If you know either the degrees, you can find the radians, and if you know the radians, you can find the degrees. So it says express 35.65 degrees as radians rounded to decimal places. So let's take a look at what that is. All right. So let's go back to our formula. We said degrees over radians equals 180 degrees over pi. Okay. So I can now plug in degrees, and I'm going to flip this. So I'm going to say pi over 180 degrees is equal to r over 35.65 degrees. Sorry, lost my train of thought. All right, so we just bring this up top, and we're going to say 3.14 times 35.6 degrees divided by 180 degrees, and that's going to give us approximately 0.6 2 radians. All right, so let's see how they did it. See, we're on the right track. Yep, says that. Yep, proportion. Yep, 0.62 radians. Check it out. Again, set up the proportion 35.65 times pi over 180, and it gives us our radians. And again, we can go back and forth. If we had radians, we could figure out degrees just as easily. So let's talk about some postulates, okay? And postulates are nothing more than they are the rules for the object. The mathematicians came up. This is how these things work. So all radii of the same circle or congruent circle, remember congruent means the same, are equal. Well, sure. If I have a circle and I'm coming from a center point, the radii will all be the same, no matter where they shoot out, and no matter what my drawing actually looks like. The diameter of the circle bisects the circle and the surface enclosed by the circle. If a line bisects the circle, it's the diameter. The diameter of a circle is longer than any other chord on that circle. Well, that makes sense because it's a circle. It's running through the center. So as you get off center, the chord gets smaller and smaller. A straight line passing through a point within a circle intersects the circle at only 2 points. Sure, that makes sense. In the same circle or in equal circles, equal chords subtend to cut off equal arcs. The same circle or in congruent circles, equal central angles subtend cut off equal arcs. In the same circle or congruent circles, two central angles have the same ratio of arcs that are subtended or cut off by the angle. Let's see what this actually looks like. A diameter perpendicular to a chord, the chord and the arcs are subtended chord. The perpendicular bisector of a chord passes through the center of the circle. All right, so let's actually do something. All right, so these are congruent. Okay, the circles are the same. All right, and it wants to know what? It wants to know the arc of E and F and the angle of GOH. All right. Remember, we're all about proportions. Okay. So, what do we want to start with? Let's start with E and F. Okay. Now, actually, let's start with GOH. All right. So, GOH, I know that, and I'm looking for O right here. Okay. I know that we have 75 degrees in an 18-inch segment, which is going to be equal to GOH over 24 inches. Okay. So again, I'm going to bring this up. So 75 times 24, 75 times 24 divided by 18. That gives me 100 degrees. Okay. Now it wants to know E and F. It wants to know what this is right here. Well, check it out. We've got, again, we have So we're looking for E and F. So we have EF over 42 degrees is equal to 75 degrees, because that's known, and 18 on top. All right. So this is going to give us the length of that part of the arc. So we're going to go ahead and do 42, because remember, going up, times 18. Yep. And then divide that by 75. And it gives me 10.1 inches. So you set up your portion and go. So let's see. CD. All right, talk about that. Yep, set it up. 10.08, I 10.1 because I rounded. And GOH, 100 degrees. Same approach, same way. Yeah. So just make sure you're setting up your proportions properly in order to do that properly. A line perpendicular to a radius at its extremity is tangent to the circle. A tangent to the circle is perpendicular to the radius. That makes sense because it touches the circle at only one point, and the radius coming down will be tangent to it, will be perpendicular to it. Two tangents drawn in a circle from point outside the circle are equal and make equal angles with the lines joining the point. If two chords intersect inside a circle, the product of two segments, equal products, two other segments, blah, blah. All right, so check this out. It's wanting to find out, and this is tangent, right? This line right here, AB, is tangent. It's only touching at point C, all right? And it wants to know what AO is, or OA, or however you want to say it. Well, I know two sides, and you see this radius here? If that is 7.35, this as well will be 7.35. Just carry the radius, slide it around, and put it in place, boom. So I've got good old Pythagorean, 8 squared plus b squared equals c squared. So we're going to do 7.35 squared plus 9.25 squared. And then we'll get the answer and have to square root it. Don't forget about square rooting it. So you got 9.25 squared, 7.35 squared. That gives us 139.585 meters squared. But now we need to do the square root of that. And that's approximately 11.8 meters, rounded to one decimal place. And on the test, or before the test, I'll indicate how many decimal places you should go on any given test. All right. So here's another thing based off those postulates. It says determine the length of EB in the figure given below. Given that AE is 4.5, so 4.5. CE is 15, and then ED is 3.4. So this is actually a pretty simple setup. You're going to put, well, I guess there we go. CE and ED multiplied together, and then you're going to put A and EB. And since we're looking for EB, it's going to be 4.5 times EB equal to 15 times 3.4. All right. To get EB alone, we divide 4.5, gets rid of this, and put 4.5 underneath there. And we calculate, so we go 15 times 3.4 divided by 4.5, 11.3. Let's see what they determined it to be. 11.3. Sweet. Angles inside a circle. An angle formed by two chords that intersects within the circle is measured by 1/2 the sum of its two intercept arcs. An inscribed angle is measured by 1/2 its intercepted arc. An angle formed by a tangent and a chord at the tangent point is measured by 1/2 the intercept arc. All right, so let's take a look at that. So, inscribed angle right here, B. All right, and we've got 103 degrees on the outside. So, based on the postulate, the inscribed angle is measured by 1/2 its intercept arc. So, 103 divided by 2 is going to give us 56.5 degrees. Oh, 51.5. Oh, mental math, sorry. 51.5 degrees, or 51 degrees, 30 minutes. All right, cool. Now, if we look at this, all right, AD is 109, BC is 43. So now it's 109 minus 43 degrees. Put parentheses around that, divide that by 2. So we go 109 minus 43 equals divided by 2. So it will be 33 degrees. All right, let's check that. 33 degrees. All right. So pretty straightforward stuff. If you have questions, please email me, text me, whatever, call me. And if you have specific questions on specific problems, shoot me an email with the problem. I'll make a video covering and showing you how to do the problem. Hope you guys have a good rest of your week and stay out of trouble. Look forward to seeing you guys on next Wednesday. Like really, really, really do.